Okay, let's start over with Qt for Mqtt. Every time I have a question about Mqtt, I'm going to Maurice. So I thought that would be also a good idea that you have questions later on about Qt and learn about something, a little bit about that. So warm welcome for Maurice Kalinowski. He is a dynasty of the Qt company, and he will tell us a little bit about our activities there.
Well, thank you very much for that warm introduction. And also, I'm surprised to see so many faces here, as I'm the one holding you back from the beer. So, thank you for coming. As Lars already said, my name is Maurice Kalinowski. I have a history of 11 years in the Qt company. I have been working on Windows CE back then, porting QtWS platform. So I have also some history in the embedded segment, also taking care of Windows 10 IoT Core now, and now since, I believe, half a year, joined the automation team and taking care of Mqtt first. So, whom of you has been attending the Qt for Automation talk by Lars? Okay, that's most of them, so I can be pretty quick on that one. Mqtt is part of Qt for Automation, which is a product which we launched in August, and Lars has been doing a presentation on as well. It's an add-on for Qt for application development, as well as Qt for device creation. And on the initial release, we wanted to focus, or we have been focusing on Mqtt as an M2M protocol, as well as KNX for building automation. Continuing my questionnaire, whom of you is familiar with publish and subscribe protocols? That's way more than in the rehearsal. Whom of you is familiar with Mqtt as a protocol itself? That's a bit less, but still, I'm surprised. Okay, so let me maybe speed up on this one. So Mqtt is an open standard by the OASIS. The OASIS takes care of many M2M and IoT protocols, also AMQP, etc. So if there's anything in terms of communication protocols, that's really the place to look at. The current version is Mqtt 3.1.1, but most people call it Mqtt 4. And Mqtt 5 is currently in public review stage, meaning it is mostly done. My expectation would be that within the end of 2018, you would also then see that implemented in Qt and then also on most other implementations as well. I already indicated it when we're talking about Mqtt. It's a publish and subscribe method. And for the few of you who don't know publish and subscribe, maybe do a quick introduction. So you have a couple of clients, and we start with the first one. In the Mqtt context, it doesn't matter if it's a device or a telemetry application. Every Mqtt client connects to a broker, meaning to a server. And once that connection has been established, also other clients can connect. What happens afterwards is that certain clients can subscribe to a specific topic. So in that case, client 2 subscribes to topic A, and client 3 subscribes to topic A and B. And if your sensor is now sending data via Mqtt, it publishes a message, and the message always has a topic and a payload, the content, meaning what is the actual data people might be interested in. So in that example, it's sending a message under the topic A with the content XYZ, and both do receive that message. If the client were to publish a message under the topic B, only client 3 would receive it because he was the only one interested and who subscribed to that topic. So much for publish and subscribe in general approach. Specifics on Mqtt, when it comes to security, it relies on mostly 2 items. One is that it has an inbuilt authentication system that is standard username password. And when it comes to the transport layer in itself, it relies on SSL or TLS. So there's no inbuilt encryption or such in the protocol itself. It relies that the transport takes care of that. Quality of service levels. There's 3 defined levels by Mqtt. 0 means fire and forget. It's usually like sensors sending out mass data, and if you miss one mark, it doesn't matter. 1 is you get an acknowledgement, so the sensor knows the data has been received by the broker. And quality level 2 means also that the message has been handled by someone else properly already. That is, for instance, important if you use Mqtt in transactional series, like in a banking system or such. You actually want to know that the transaction has been ended there before you throw the money away. And the other item, which is fairly important in Mqtt and fairly useful as well, is what is called the last will. when you're talking about that, it means that at the point in time when client 1 connects to the broker, it can set a last will, but only at that point in time, not afterwards. What the broker then does is that it stores that message as long as that connection is alive. And if client 1, the connection falls apart with not a regular disconnect, so if the TCP connection falls apart, what happens then is that the broker sends that last will message to everyone who has been subscribing to that last will topic. That topic could, for instance, also be topic A or B, just like mentioned before. But it's a fairly unique feature that you can store that message, and if the connection falls apart, you can still somewhat send a message like, okay, sorry, I died, which can still be handled then gracefully. When we're talking about topics, topics in general are in a tree hierarchy, so you have topic A / and then you go A, B, C, D, etc. What's noteworthy here is that the standard does not ask you or give any specifics on how you should design your topic hierarchy. It's completely up to your project. That is also different to some other bigger protocols where you have a predefined hierarchy set, thinking about OPC UA and OPC UA in building automation, where you have like everything set for you. So it's really up to you and your project. One additional specifics is wildcards, and wildcards is so that's something when you subscribe to a topic on a recipient end. Let's start with the hash, that's the easy one. So if you're looking at topic like you have here with A, B, ABC, so you could subscribe to A/hash, and you would receive any message on A or any other subtopic on that. The plus sign means you could put that somewhere in between. So if you use ABC, you could also subscribe to A+C, and you would get anything which matches that pattern where basically the B part can be anything. I'm not sure how many of you have seen our sensor tag demo already, but given an example of that, what we're doing there is that the Raspberry Pi, which is when publishing the data, that is sending, first it publishes always under sensors active. So you might see my desktop machine in the office as well sending that, because that one is still alive, luckily. So you would subscribe in a telemetry application, you would subscribe to, okay, which active sensors do I have? The message you receive is the ID of the sensors, which in that case would be BTLE 424. And once the sensor is then sending data, it's sending basically under sensors, its ID, and then the various sensor values and sensor data the sensor has. So what we're doing in a telemetry application then is, what you could do is subscribe, if you were interested in all sensor data from that specific sensor, you would then subscribe to sensors BTLE 424 hash. Another use case would be, you might be interested in the temperature of all sensors. So in that use case, you would use sensors plus temperature. Okay. So how does that all fit together with Qt? And what's Qt MQTT then? What we have been taking care of is the client-side implementation. So you are capable of creating devices as well as telemetry applications to gather the data. As I mentioned previously, a client is a client. A client subscribes and it publishes messages. The communication is always bidirectional, so it doesn't matter where it actually resides. But what we're not taking care of as of now is the broker side. There's quite many implementations out there already, and if you were interested in a Qt-based broker implementation, please talk to me. But also please have a unique use case why you would see that beneficial in Qt. As I've been mentioning, the current standard version is 3.1.1. Most people call it 4, but our implementation is also compatible with the version 3.1, which has been still in use by quite many. For instance, the public Mqtt server, actually, which is also one very known implementation of MQTT, that has been running on 3.1 since a couple of weeks ago, actually. So when we started implementing that one, when we thought like Mqtt is the most used one, but that was the most used old standard. So it was a bit complicated in testing first. As I have been mentioning Mqtt already, One thing noteworthy is also that we do not use any external dependencies. So it's completely implemented in Qt. We're not using, for instance, PAHO, which many implementations and many bindings are based on. So when you get Qt Mqtt, you get a full implementation in Qt and no external dependencies being dragged in. Having said that, that also has the advantage that it's running on all supported Qt platforms. So anything where Qt runs on, you can also use Qt Mqtt. Okay, maybe I should walk you around a bit. So maybe I show you first the simple example. Well, first we should start a broker. I'm going to use a test broker, which is provided by PAHO as well, which does also certification, standard applied compliance tests. So I was very unsure whether I could use the network outside here. So we're just using a local connection. So what we have here is a very simple client. You would specify a host. You would connect to it. You are connected, and you could subscribe to a message. In that case, it would be Qt Mqtt topic 1. Subscribe to it, and once you change the message to something else and publish it, you're receiving it as well. So that's like the most simple use case and actually inside of an application. To see that it's actually doing things, you can also see that it has been happening here, and these are already compliance tests running. Okay, so how does that look code-wise? Generally, it's fairly easy. The entry point is Qt Mqtt client. And if you look at the class implementation, there's a couple of properties already provided. So each Mqtt client has a unique client ID. You can manually set that, or we set one for you. You have the host name and the port you connect to. Keep alive is basically a signaling model that you can still tell to the broker that you are still alive and there is no unexpected disconnect, etc., etc. Maybe mostly all the things I have been talking about already. So when we're going back, so what you do then in this example is you create a client, you set a host name, a port. You connect to message received, which is the client in our implementation has a general message received. So any message will also signal a Qt Mqtt client message received. I will show you that in another example. You can also go to the various subscriptions and then handle that separately. But sometimes you're also just interested in all the messages you have been subscribed to, and you would just use the client then. Subscribe would then simply be on subscribe button clicked. So what you would do on connect, well, on subscribed, you simply call subscribe with the topic which has been set here. So as such, fairly simple example and fairly easy to use, I guess. Another example I wanted to show you is our subscriptions example, which is a bit more elaborate. So once again, we connect to localhost. But what we're doing now is that we subscribe to various topics. Well, actually, we could use topic. A subscription also has a QoS level. When you remember like the QoS levels a message could have, the same applies also to the subscription. So when you subscribe with a certain QoS level, it means that is the minimum quality of service level I want to have. The interesting thing is, let's assume we have our telemetry application on the tablet. That one subscribed with a QoS level 1, saying I want to have everything confirmed. But the sensor is sending everything with a QoS level of 0. Then the broker takes care of the uplifting of the quality of service. So that is why you separate between a QoS level of a message as well as a QoS level of a subscription. So what the example does, it opens up a new window, giving you basically the state of the subscription. So right now it is subscribed. That happens fairly fast on a local connection, obviously. We're also going to subscribe to maybe the Dash version I have been talking about, and maybe also to something. Okay, so now we have 3 subscriptions running. And to show you that the things are really working is, so let's send something on the risk topic. First message. So when you're publishing that, that has been received here on that one, because that is listening to Qt Mqtt /hash, so everything there. If we use topic, you would see it on those two sides, etc., etc. So let's have a quick look there, how that looks like. So what happens is that once you subscribe, you get a subscription object here. Oops, a QMQTT subscription. And the subscription itself, as I already mentioned, it stores the state of the subscription, so it can also be remotely killed, for instance, the QoS level you specified, as well as the topic you subscribe to. When you receive a message, in that case, you will receive the message, and a QtMQTT message will then contain the actual topic it has been received by. So when you're using wildcards, you have a subscription with a wildcard, but still you might be interested in the actual topic the message belongs to. So that is then stored in the message itself. Okay, timing-wise, I need to skip some other examples, unfortunately. One example had been WebSockets. I have been already mentioning that on my blog post. But the repository is open now, so you can just look at that. So that is also part of the examples directory there. The interesting thing with WebSockets is MQTT on WebSockets is currently the new hot shit. And Qt has support for WebSockets. Qt now has support for MQTT, so like, why not drag the things simply together? The one reason, or the one thing which makes it a bit more complicated is the fact that QWebSocket is not QIO device based or QAbstract socket based. And that is due to the fact that you can there's a different mean to send binary data or to send text data, etc. So WebSocket couldn't just use a QIO device based implementation. But MQTT in itself, or the WebSocket amendment, clearly says it has to be binary data, it has to fit into one datagram, etc., etc. So with that assumptions being done, you can easily create your own QIO device, which then uses the WebSocket below that. And as I've been talking about the transport layer before, maybe I just quickly show that once again, is you can set a manual transport for Qt MQTT always. So it's set transport where you can set any device type, QIO device based. And in that example, you would use a WebSocket. Yeah, unfortunately I cannot show it for timing reasons. What I haven't been able to talk to you about is also QML. We do not provide a QML API in the initial version. That might be surprising, but there's two reasons to that. The first reason is that when you are usually acting on data, you should be, in 99% of the cases, act in C++. Because you're handling data, you're then handling massive data amount, etc. So don't do the round trip first and then go back to the logic again. The other reason is that we have not fully decided if we were to provide a QML API, how would that look like? Especially in terms of the dynamic subscriptions, etc. How would we design it from an API perspective? We do have a QML example in the repository. So if you want to do that, just grab the example how to do that, and most likely it will fit your needs. But for the initial version, we have decided not to put it into the public API. What's coming next? Repositories are available. I guess that's the most important thing for most of you here. It took us way longer than we were hoping for. Apologies for that. And on Monday, Ossi put the switch so that it's now available on Gerrit. So the important thing is, right now it's available on Gerrit. If you look at code.qt.io, the mirroring has not been happening yet, so that will take a week more or such until that is also mirrored there. So if you want to have it right now, that's the address. I have been talking about that it's part of Qt for Automation, so it's dual license under GPL as well as commercial. And our release target for MQTT is within the Qt 5.10 timeframe. When it comes to feature developments in the MQTT side, I have been talking about MQTT 5.0 already. So once that standard has been set in stone, we will clearly need to invest into that. MQTT-SN is an interesting topic, but we haven't seen use cases out in the field so far. So if you have been using MQTT-SN, please come to me and talk to me about that. For those of you who don't know that, the idea of MQTT-SN is that you can shrink the data even further. right now, when you're sending a message or publishing a message, you are sending a topic, and a topic is a string, which can be, well, fairly long. With Mqtt you have IDs for the string. So you would create a topic and you would get back an ID and you would only then send that small number instead of the whole string. That's one of the advantages why Mqtt can shrink in the protocol even further. Once again, we've only seen the standard and many people like it, but we haven't seen it out in the field. So I would be really interested to see use cases from your side. When it comes to embedded, we haven't been looking into the Octo integration yet, but should be fairly easy to do, but most likely will not make it within 1.0. And the feedback we have been receiving so far already is in terms of local persistence storage. That's a feature which some other implementations, especially in other languages, provide. So when you're publishing a message, you get back the acknowledgement. If you don't get it back within a certain amount of time, you want to send the message again, and you have a duplicate flag also inside of the message. But right now, you would need to take care of that process. So you would receive a message send signal once the message has been sent, but you are still responsible for keeping the message in your application. But the feedback has been already that they would like to see us doing something there, that you could create your own message queue, and then Qt takes care internally about when the message is sent, etc. And within the broader context of M2M protocols and Qt for automation, there's also other protocols we're looking into, and that's once again where we are inviting you for feedback, what's important for you. Big topics are obviously OPC UA, DDS, AMQP I have been mentioning in the beginning as a comparison to MQTT, but it seems like MQTT has won that race. And other protocols as well, but once again, looking also towards for your feedback. With that having said, that concludes my presentation. Any questions from your side?
First, thank you.
There was one person, yeah.
Just a question, what is the license of Qt?
It's dual license?
GPL, yes, GPL or LGPL?
GPL.
GPL.
Yes.
That means that we have to make it open source if we want to use it.
That's the short summary, yes. Any other questions? Yeah.
On which level is the keeping alive of the connection handled? Because if you subscribe to a topic,
yep,
you need to somehow take care that you have a connection.
Right.
Is this handled in somewhere in the Qt system, or is this?
So there's
rely on the operating system?
There's two things. MQTT relies by its standard definition that it has to be a lossless connection, it has to be ordered, and it has to be bidirectional. So as such, TCP is in 99% of the cases being used with MQTT. And as such, with QTCP socket, we also take care then that, it's the underlying operating system taking care that the TCP connection works. The other thing is, if the connection gets slow, you have that ping-pong mechanism inside the standard as well. That's the keep alive as a property, which says that a client will send its keep alive ping message the standard is, I believe, every 5 or 30 milliseconds. 5 or 30 seconds. So that's the two mechanisms.
So this would take care of keeping alive the connection.
Yeah.
So I could have the client on a smartphone and it would somehow keep the connection to the broker open.
Yes, yes.
So the smartphone is a good hint. So we have on the Google Play Store the app for the sensor tech demo. You can see it at our booth. You can even download that app on your Android device if you want. Just look for Qt sensor or so, and you can see that demo as well.
And one additional comment, you also in Qt can check, there's also classes to check if the wireless connection is still alive, if it has died, etc. So we'd use that one. It's not inbuilt into Qt MQTT. But what you would get is, if the TCP connection falls apart, you would get a disconnected signal from the Qt MQTT client. And then you either manually reconnect, or first try to verify what is going wrong so that you're not pulling the connection.
So basically I could use this in an app to implement a receiving push notifications from the server? Yeah,
could be an option, yes. Yeah. MQTT has been used many, many years ago by Facebook, actually, to do their messaging protocol. One more question, yeah.
You mentioned QtTSN for compressing.
Yes.
Do you know by any chance whether the AWS MQTT server supports that already?
I wouldn't know. No, sorry. So the question was whether the AWS server supports that, and I wouldn't know. Sorry. No.
Any further question? Of course, you can also get in touch later with Maurice, so at least at a beer. Okay, then thanks again. And so that was the last session for today.
Yep.
Hopefully see you again tomorrow.
Thank you very much.